So more than anything else, this one topic seems to be confusing the most of you with inequalities. So for inequalities, what I want you to do is I want you to graph it. There is another way to do it, but so much of this chapter focuses on graphing, so why change the channel? Let's just stick with graphing. So the first thing you need to notice is when you have an inequality, everything needs to be on one side of the equation. So the first thing I'm going to do is I'm going to rewrite this. Negative 2x squared plus 4x plus 6 is less than 0. So just set it all equal to 0. So we're going to see which values of this are going to be less than 0. They're going to be below the x-axis because anything below the x-axis is less than 0. Anything above the x-axis is greater than 0. So I can look to see if I can factor this, but don't waste any time trying to factor it. You can always use quadratic formula. So I'm just going to plug this in the quadratic formula. So opposite of b, plus or minus b squared, which is just 16, minus 4 times negative 2 times positive 6, all over 2 times negative 2. So I end up getting 4 plus or minus the square root of 64, all over negative 4, which is negative 4 plus or minus 8, all over negative 4. And I'm assuming you know how to evaluate those. You're going to get two different values, right? So we're going to get, I already did this ahead of time, negative 1 and positive 3. So I'm assuming the quadratic formula is not what is holding you guys up. So the quadratic formula, remember, this is huge. This gives us, the quadratic formula gives us the x-intercepts, right? This whole thing gives us the x-intercepts. So let's just go ahead and graph this guy. So this is going at negative 1 and positive 3. These are my x-intercepts. That's what I just found. Now the other important thing that you really need to notice is that, let me point to this guy. This guy, see this thing here, this negative 2, this thing tells me that this parabola opens upside down, right? So make sure you're looking at that. If you want, you could take the time to find the vertex. If you took the time to do negative b over 2a, you would get a vertex here, which would clearly tell you that the vertex is above the x-axis. If it were a positive parabola, you know, the vertex would have been down here somewhere, but because it's negative, it's up here. So you would have, if you evaluated negative b over 2a, but I don't really need, if all I'm asking you to do is tell me where this thing is less than 0, I don't really need the vertex, okay? It's a good thing to know how to do, but I'm not asking for it in this situation. So now let's look at our graph and let's answer our question. So the graph that is less than 0 is, I'm going to draw over this, is this part of the graph, right? These legs of the graph are below the x-axis. They are less than 0. So we're going to use our interval notation to describe that, and that becomes negative infinity 2, and then what is that x-intercept? That's negative 1. And I'm going to union that with 3 to positive infinity, because those are the legs that are less than 0. If I had asked if it was greater than 0, right, greater than 0, hold on, oh, I don't want that, sorry. Okay, so these values here are greater than 0, right? This part of the parabola is greater than 0, so my answer would have been just one interval from negative 1 to positive 3. So negative 1 to positive 3 is greater than 0, but these two legs are less than 0. So let's do another example. So let's say we have, 2x squared plus 4x plus 6 greater than 0, say for example. So I'm changing, this is a little different. This is a positive parabola. I kept the numbers the same. So if I do my quadratic formula, because that I need to find my x-intercepts, right? So I'm going to do negative 4 plus or minus b squared minus 4 times 2 times 6, all over 2 times 2. So I end up getting negative 4 plus or minus the square root of negative 32 over 4. Ooh, so you guys hopefully are looking at this going, whoa, wait a minute, negative square root of negative 32, these are imaginary numbers. So this parabola looks like this. Actually, this is one situation where we are going to need to know the vertex, because I don't know. All I know is that this guy has no x-intercepts, right? No x-intercepts. So this thing is either above or below the x-axis, okay? Oh, actually, I can tell. Because it's positive, because this guy is positive up here, I know that it's going to be above the x-axis. But what I would recommend you do is now this is a situation where we're going to find the vertex. So my vertex is going to be -4 over 2 times 2, so that's going to be -1. And when I plug in -1, I'm going to get 2, that's 4 plus 6, I'm going to get +4. So my vertex is going to be at -1, 4, so that's going to be my vertex there, and I know this parabola is going like this, and therefore no x-intercepts. So let's answer the question though. Where is my parabola greater than 0? Still a valid question. Even though it doesn't have any x-intercepts, this question is still valid. So where is my parabola greater than 0? Well, everywhere it's greater than 0. All of it. None of it is below the x-axis. So my answer would be -infinity to +infinity. Okay? And then be careful. Sometimes when you do you end up, when you do your quadratic formula, you might end up with something like this, square root of 40 over 2. Okay, so you can equate those to decimals, hopefully. So I got 5.16 and -1.16. And, so this parabola, that's okay. Sometimes your x-intercepts are decimals. 5.16 and -1.16, that's fine. And if my parabola, I don't have the equation of it, but let's say my parabola goes like this. Again, once I find my x-intercepts, I can say, okay, well, this guy is greater than 0 from here to here. So greater than 0, the interval would be -infinity to -1.16. Oops, sorry, my writing's bad. And I would union that with 5.16 to infinity. And then over here, I'll say, how about less than 0? Well, it's less than 0 all here, right? So that is simply the interval -1.16, 5.16. So I hope that helps.